Take an example. The function f is such that real to real defined by f of x is equal to x by x square plus 1 is neither 1 1 nor on 2. Prove that f of 2 is equal to 2 by 2 square plus 1 is equal to 2 by 5. F of 1 by 2 is equal to 1 by 2 square plus 1 is equal to 1 by 2 1 plus 4 by 4 is equal to 2 by 5. Now, f of 2 is equal to f of 1 by 2 which is equal to 2 by 5. So, it is many one, not 1 1. If x by x square plus 1 is equal to 1 which is belongs to R. So, x is belongs to x square plus 1, x square minus x plus 1 equal to 0, x is equal to 1 plus minus 3I by 2 which is belongs to complex. So, roots are not real, hence 1 has no pre-image. So, f is not on 2. Another question, f such that real to real is defined by f of x is equal to 1 plus x square 1 1. Let x1 x2 belongs to real. Let f of x1 is equal to f of x2. 1 plus x1 square is equal to 1 plus x2 square. So, x1 square is equal to x2 square. Directly you can say x1 is equal to plus or minus x2. So, f is not 1 1, hence it is many one. Now, on to let y is equal to f of x is equal to 1 plus x square. That implies x is equal to y minus 1 ka root over. When y belongs to real, x is does not belongs to real. So, codomain is not equal to range. That means here range is equal to real plus and codomain is equal to real. So, f is not onto. Another question. Let A, B, B two sets so that f such that A to B, A cross B to B cross A is defined as f of A B is equal to B comma A. Now, prove that 1 1. Let A1 B1 A2 B2 belongs to A cross B. Let f of A1 B1 is equal to f of A2 B2. So, B1 A1 is equal to B2 A2, B1 is equal to B2, A1 is equal to A2. So, f is 1 1. Now, on to let L B comma A belongs to B cross A, B any element. Let y1 y2 belongs to f b that is equal to B comma A. So, a y1 is equal to B, y2 is equal to A. Then there exists A comma B belongs to A cross B such that f of AB is equal to B comma A. So, codomain is equal to range, hence f is onto. Thus, f is bijective. Another important question. Let f such that natural number to natural number be defined by fn is equal to n plus 1 by 2 if n is odd for all n belongs to natural number, n by 2 if n is even. Answer. Let n is equal to 3 which is equal to odd, then f of 3 is equal to 3 plus 1 by 2 is equal to 2. If n is equal to 4 that is even, then f of 4 is equal to 4 by 2 is equal to 2. So, f of 3 is equal to f of 4 is equal to 2. It is many one, but it is not 1 1. Question asking that is it bijective? If 1 1 is not satisfied, then it is not bijective. If it is asking that is onto or not, then here codomain of f is equal to natural number. Case 1 n is odd, that means 2r plus 1 r is belongs to natural number. That implies 4r plus 1 is belongs to natural number. So, f of 4r plus 1 is equal to 4r plus 1 plus 1 by 2, that is 2r plus 1, that is odd. Case 2 n is even, n is equal to 2r, that r belongs to natural number. That implies 4r also belongs to natural number. So f of 4r is equal to 4r by 2, that is 2r, which is even. Hence f is 1 on 2, that since codomain is equal to range. Thus f is not bijective function. Now what is composite function or composition of a functions and invertible function? Definition. Let f such that a to b and g such that b to c be two functions, then the composition f and g denoted by g is defined as the function g such that a to c given by g of x is equal to g of f of x for x belongs to a. So that is here a set, here b set, here c set, a to b that is f function, b to c that is the g function. So x पुट होने के बाद f of x मिला, that is equal to y let. So y पुट होने के बाद g of x, g of f of x और g of y मिलेगा हमको, g of y. So that is which is equal to g of x. Directly a to c, that is g of. Example, given a set given, b set given, c set given, and function map f and g given. F of 2 is given 3, f of 3 is given 4, f of 4 is given 5, f of 5 is given 5. G of 3 is given 7, g of 4 is given 7, g of 5 is given 11, g of 9 is given 11. So g of 2 is equal to 7, 2 is directly 7. G of 3 is equal to 7, g of 3 is directly 7. G of 4 is equal to 11, that is 4 डालने से g of under, that is 11. So g of 5 is equal to also 11, that is also comes 11. So take another example. F such that real to real, g such that real to real are given by f of x is equal to cos x, g of x is equal to 3x square. So g of x is equal to g of x, g of cos x. In the place of f of x you put cos x. So in the place of x here you put that is cos x, that is in the place of x here you put cos x. Similar 3 cos square x. So fog of x is equal to f of g of x. In the place of gx you have to put 3x square. So here in the place of x here you have to put that is 3x square, that is cos 3x square. That means g of x is not equal to fog of x. Another example that is given. So that if f such that a to b and g such that b to c are 1 1, then g of such that a to c is also 1 1. Solution. Let x1 and x2 belongs to a. Let g of x1 is equal to g of x2, g of f of x1 is equal to g of f of x2, f of x1 is equal to f of x2. Since g is 1 1, x1 is equal to x2, since f is 1 1. Now you taken g of x1 is equal to g of x2, you got x1 is equal to x2. So g is 1 1.